Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in the easy manner. Now today we are going to start the very interesting and very easy and very tough for you, the chapter called the organic chemistry. Clear? Now by listening the chapter name or by listening the chapter or by listening the name itself, many of the students they will feel something else it is there in the organic chemistry, but very less concept and very high application that it will be there in the organic chemistry. Many of the students they will feel that by seeing the question without the pen, the questions they may attempt, that type of the questions are only the organic chemistry questions. Within fraction of seconds we can do the question what they have given in our exam. But to be like that, by seeing the question itself, to tackle that answer, before that one we have to be strengthened in the application part. Concept is different and approaching to the application is different. To be strengthened in the application part, what we have to do? What are the basics apart from the organic? What are the basics to be remember? Those basics we have to apply in the question and we have to apply in our organic concept. That if you be strengthened and if you are able to identify and what is the concept that it was involved over there and how we have to apply that concept to the given organic questions, if we have strengthened those one, the entire organic chemistry will become very easy. If those concepts or if it is not clear for you, the entire organic chemistry will become very tough for you. So to start the organic chemistry, I just want to give a quick recap of the basics which are involved in our organic chemistry, so that it will not make you any hectic while solving the questions or while understanding the concepts also. Clear? Now let's start those application of the basics which we are going to involve in the organic chemistry. Okay, now let's start and we make that, I will make those basics to understand clearly and I will make your life very much easy in your organic chemistry if you follow my lectures daily. Okay, now let's start our lecture. Now before starting the organic, now first we have to strengthen in this concept. If we strengthen, we know we have studied this concept in our starting of our class 11th itself, but many of the students what they will do, many of the students when they start the organic chemistry, they will forget the whatever they have studied in the previous lecture. So that the quick recapping of the previous lecture, those it will be involved in our entire organic chemistry. Clear? First we have to see the concepts of the how the atomic structure is involved and how it is playing the very crucial role in the organic chemistry. And the next bonding. In that bonding, the first we are going to, this will play very crucial role, electronegativity. Where the electronegativity will play very crucial role, that I will explain. How? If they have given a one HBr, let us assume HBr they have taken. In the HBr, that is a reagent. How it will be dissociate? H plus and the Br minus. How? Why only H plus and why only the Br minus? That concept it will be explained by the electronegativity. Clear? Next we have to know which are the metals and which are the non-metals. Okay, next we have to see the octet. We know already what is the meaning of the octet. Electron, every atom want to attain the octet electronic configuration to become stable. So this word stability, the word stability we are going to use in our entire organic chemistry. Clear? Next dipole moment. See this dipole moment, how it will play very important role in our organic chemistry. This dipole moment concept will play very crucial role in the identification of the polar and the non-polar, polar compounds and the non-polar compound, and the polar solvent and the non-polar solvent, and cis and trans. Among the cis and trans, which is a polar and which is a non-polar also, there it will very crucial role it will play. Next, covalent and the ionic bond. Clear? This many of the organic compounds it will form the covalent bonds itself. So first of all we have to try to understand how the covalent bonds are forming, how the ionic bonds are forming. Clear? Now majority of the organic bonds will form the covalent bonds itself. Clear? Next, valency electrons. Many of the students, they may get a confusion in the identifying of the valency electrons. Now this identifying of the valency electrons, it will make you, because many of the students, they will face the very much problem in the organic chemistry without identification of the lone pair. See, they will give you some OH like this. Let's assume this is the alcohol functional group. In this alcohol functional group, how it will play a very crucial role, and they will ask you how many lone pair of electrons are there. Then this valency electrons will play a very crucial role. Clear? But in the exam, they will never and ever mention the which one lone pair of electrons on the atom. That's the reason many of the students, they will face a problem while solving the questions. Lone pairs, they will never and ever they will mention on the atom. Clear? Next, Lewis structures. So that Lewis structures, it will helpful for us how the bonds are forming. That one bond contain how many electrons. Clear? Next, Lewis acids and the Lewis bases. Identification of the Lewis acids and the Lewis bases are also will play very key role in the identification of the reagents. Best example I will take you, just to make you to understand, I will take the AlCl3. AlCl3 is a one Lewis acid. It will play very crucial role in the which one? Aromatic electrophilic substitution reaction. In the aromatic electrophilic substitution reaction, we are going to study one reaction called the Friedel-Crafts alkylation. There this Lewis acids will play very crucial role. So what is the role of the AlCl3? What is the role of the Lewis acids? I will explain. Clear? Now next, lone pairs. Already I said you, lone pairs they will not give you. Next, this is a very key point, that is known as a hybridization. Clear? And the next one is a formal charges. Formal charges. Clear? Now one by one we will study this concept which we have learnt in the last class or in the starting of our class 11th. So that if we recap, quick recap, if we do this one, so that we may not get any difficulty while we are applying the concept. These are the application of the organic chemistry. These are not the concept. These are the basic applications. This have to remember, and whatever the concept you have learned, this concept you have to apply to the organic chemistry questions. So how you have to apply to the organic chemistry questions? With the help of the questions and with the help of the concept, I will explain one by one. Okay. Now let's start our. First we are going to study about the atom. Sir, we know about the atom, but what it will play a very crucial role? Why we have to study about the atom? We know that atom, it contain proton. Atom, it contain the nucleus. That nucleus contain the proton and the neutron. And the electrons are the negative charge. Electrons are the negative charge that it is revolving around the nucleus. Here, based on this atom only, our entire organic chemistry has been divided. Electron breaking. If you break the bond, electrons will be split. Now delocalization, if you talk, electron will be moved from the one atom to the another atom. Clear? Now carbocation, if you want to make the cation, you have to remove the electron. If you want to make the anion, you have to add the electron. So entire organic chemistry, now it will be depend upon the electron itself. Clear? Where this electron has came? Now this electron, about this electron we have studied in the structure of atom. Clear? Now you know this is a proton and this is a neutron, and the electron is a negative charge. Electron is a negative charge. Before going to start this one, I just want to ask you that this orbit n is equal to 1 orbit, n is equal to 2 orbit, this is n is equal to 3 orbit, this is n is equal to 4 orbit, like infinity orbits we are having. But why I want to explain this one? First I want to explain, first orbit can accommodate how many subshell, or first orbit having how many subshell? That is 1s. Clear? Second orbit we are having 2s and 2p, and third orbit we are having 3s, 3p and 3d. Clear? And fourth orbit contains 4s, 4p, 4d and 4f. Sir, why you are explaining this, sir? Already we have learned. Why I was explaining this one? Because if you able to remember this atom electronic configuration, you will not get any difficulty while you are understanding the Lewis acids and the Lewis bases. This will helpful for you how the atoms are accepting the electrons. Now how they are giving the electrons and how many valency electrons are there. Now you know from this nucleus the last shell we call it as a valency shell, right? The last shell we call it as a valency shell. Clear? Identification, remembering 1s, 2s, 2p. Now s can accommodate only 1. Now 2 can again the s can accommodate only 1, or s can accommodate 2 electrons and it is having only 1 orbital. Clear? Now it is having 3 and it can accommodate 6 electrons, and the d it is having the 1, 2, 3, 4, 5 orbitals and it can accommodate the 10 electrons. This is about the atom. Clear? Why I was explained this one? You are able to identify how many orbitals are there. This will helpful for you in the hybridization also. While we are studying the hybridization also, electron will be excited to the d orbital. Electron will be excited to the s2p orbital. Clear? There you will not get any difficulty. So that's the reason I explained about this one. Okay. Now next we'll move to the valency electron and covalency. What is the valency electrons and covalency? First of all, we'll talk about the hydrogen. Hydrogen, it is having the only one electron. Next comes to the helium. Helium, it is having only two valency electrons. Clear? Now comes to the lithium. Lithium, now it is having the two shells and it is having the only one valency electron. Clear? So that this electron I was representing in the cross. Done? Now I will write the third period elements. Lithium is having the one valency, beryllium is having the two valency, boron is having the three valency. Now carbon is having the four valency. Now this is only will play very crucial role. Clear? Next nitrogen, it is having the 5 valency. Next oxygen, it is having the 6 valency. Done? And the fluorine, it is having the 7 valency. Clear? And neon, it is having the octet. And helium, it is having the duplet. Configuration, and neon, it is having the octet configuration. Clear? This is about the valency electrons. In these valency electrons, clear? In these valency electrons, now what we are going to see here, what is the role of the valency electron? How many valency electrons are there? That many bonds it will form. Listen, what is the role of the valency electrons will play? How many valency electrons are there? That many bonds will be formed. So here, if I ask what is the covalency of the lithium, if I say covalency of the lithium is 1 because it is having the valency electron 1. Covalency of the beryllium 2. Covalency of the boron 3. See, covalency of the boron is 3. Carbon covalency is 4. Carbon maximum to maximum it will form the 4 bonds. Maximum to maximum it will form the 4 bonds because its valency electrons are 4. This will play very crucial role. Done? Comes to the nitrogen. Nitrogen, it is having the 5 valency electrons, but it will not form the 5 bonds. Oxygen, it is having the 6 valency electron, but it will never and ever will form the 6 bonds. Fluorine, it is having the 7, but it will never and ever will form the which one? 7 bonds. Why it will not form? Now I will explain. Now listen. Just now I explained you about the which one? About the atom electronic configuration, right? Now this is 1s. Clear? Next comes to the 2s and comes to the 2p. 2s and the 2p. Done? Clear? Now I just want to write for the oxygen. I just want to write for the oxygen. Oxygen, now we are having the how many 6 valence electrons. So we have expecting, arbitrarily I was saying, we are expecting to form the 6 bonds. Let us assume like this, something 1 2 3 4 5 6. So as per the covalency, oxygen should form the 6 bonds. 1 2 3 4 5 6. We are thinking, but why the oxygen is not forming the 6 bonds? Why it is not having the capacity to form the 6 bonds? But when it comes to the sulfur, in this family only, right? Sulfur, in this family only the sulfur is there, but sulfur is having ability to form the how many 6 bonds? Where we have seen this sulfur is forming the ability to form the 6 bonds, that is H2SO4. In H2SO4, sulfur is able to form the bond how many 6 bonds in this manner. Sulfur is able to form the 6 bonds, but oxygen is not able to form the 6 bonds. Why? Because now you see, what is the atomic number of the oxygen? Atomic number of the oxygen is 8. So we have to fill the electrons of 8 electron. 1s2, 2s2, 2p4, 2p4. Clear? Now here, to form a bond or to complete its octet, every atom or every element want to attain the noble gas electronic configuration to feel the stability. Done. This oxygen to complete its octet, how many orbitals are having the half field? How many orbitals are having the half field? Only 2 orbitals are having the half field, right? So the 2 orbital, they can accommodate the electrons in this. They can accommodate the electrons in these 2 orbitals. They can accommodate the electrons in these 2 orbitals. That's the reason oxygen. And if they want to extend their octet, there should be have any vacant orbital. But 2p, but second orbit, we are having the 2s and the 2p. There is no any such type of the 2d orbital exist. That's the reason it cannot extend its octet. Oxygen cannot extend its octet. Oxygen can't extend its octet. It can't extend its octet. That's the reason why it's not extending its octet. That's the reason why it is not extending its octet, due to absence of d orbital. Due to the absence of d orbital, it cannot extend its octet. That's the reason oxygen will form only double bond. Oxygen will form only the double bond due to the presence of this due to the presence of this half filled 2 orbitals. These are forming the 2 bonds, and you see, and remaining 2 orbitals are not participated in the bond, right? These orbitals we call it as a lone pairs. The which has not participated, electrons which are not participated in the bond formation, those type of the electrons we call it as a lone pairs. Clear? One oxygen contain 2 lone pairs. Clear? Now done. This is about the how to identify which one, how many bonds it will form. Lone pair of electrons, how many valency electrons are there, that many bonds it will be formed. Only it will be applicable up to the which one? Carbon. How many bonds it will form? Actually the definition of the covalency is how many bonds it will be, how many covalent bonds it will be able to form. That is known as a covalency. How many bonds that atom may be able to form, that is known as a covalence. Then when it comes to the nitrogen able to form the triple bond. So we can say it as a which one? Nitrogen covalency is 3. But nitrogen covalency is not the 3. See, normally nitrogen it will form the triple bond. Why the nitrogen it will form the triple bond? Now you see, this is 1s. Now when it comes to the 2s and the 2p, here it is a 2s and here it is a 2p. Here we are having the 1, 2, 3. Here we are having the 3 half-filled electrons. These 3 half-filled electrons, it will form the bond with the another nitrogen. Clear? And we are having the one unbonded electrons. This was not participated in the bonding. These 2s orbital electrons are not participated in the bonding. The electrons which are not participated in the bonding, we used to say it as a lone pair. So nitrogen, it contain one lone pair. Done? Clear? Now you see. So we can say that nitrogen, the covalency is 3. But nitrogen covalency is not the 3. What the definition of the covalency I said? Covalency. What is the definition of the covalency I said? How many bonds it may able to form? How many bonds it may able to form? That is known as covalency. Clear? Now you see. When it comes to the nitrogen, we thought that nitrogen covalency is 3. But nitrogen covalency is not the 3. Nitrogen covalency is the 4. Why the nitrogen covalency is the 4? This is the ammonia. Ammonia, this lone pair of electron as given to the one electron deficient species in the form of coordinate covalent bond. To the hydrogen. Clear? Now when it has given this electron to the one electron deficient hydrogen, it is forming the one another type of the bond. That type of the bond we call it as a coordinate covalent bond. We are going to study very clearly about this one. I will explain. Clear? That's the reason nitrogen covalency is 4. Why? Due to the one extra coordinate covalent bond. Due to the formation of the one extra coordinate covalent bond, it is having its covalency is 4. So when it comes to the fluorine covalency is 1. Fluorine covalency is 1. Why the fluorine covalency is 1? Because if it is taken the 1 electron, it will reach its octet. Now carbon, when it has taken the 4 electron, it will reach the octet. Nitrogen, when it has taken the 3 electrons, it will reach to the octet. Now here oxygen, if it is taken the 2 electron, it will reach to the octet. Sir, you may get it out. Sir, when the nitrogen, if it has given the 2 electrons in the form of coordinate covalent bond to this hydrogen, whether its octet has been completed or not, sir, it will also complete. With the 4 bonds also, nitrogen octet will complete. With the 3 bonds also, nitrogen octet will be complete. Now you see here, every atom to attain the noble gas electronic configuration, it should have the 8 electrons. How it is having? Now you see here 1 electron, here 2 electron, 3 electron, 4 electron, 5, 6, 7, 8. Clear? 1 nitrogen, 8 electrons done. Here this 1 nitrogen, 8 electrons done. Clear? Now here when it comes to this nitrogen, this nitrogen 1 electron, this coordinate covalent bond means that valency, this lone pair of electrons will be sharing between these two, nitrogen and the hydrogen. Okay? Now here you can see, here it is 1, here it is 2, here it is 3, here it is 4, here it is 5, here it is 6, here it is 7, and here it is 8. Total 8 electrons has been done. One bond contain 2 electrons, right? One bond contain how many electrons? 2 electrons. Clear? Now next we are going to move to the electronegativity. Clear? How this electronegativity will play a very crucial role in our entire organic means, it will, if you remember this electronegativities, what it will happen? It will make you to understand which is the polar, which is a non-polar, which is a polar and which is a non-polar. This or which is a ionic and which is a covalent. If you remember the electronegativity, actually whatever this electronegativity values they have given, actually these are experimentally they have given. How it has came, that actually I was already explained you in the classification of the periodic table chapter. You can go and see over there. Done? Now you see in our entire organic chemistry or entire chemistry, which is a more electronegative atom if I ask, That is, we used to say fluorine is a more electronegative atom, we used to say, and its electronegativity value. What is the electronegativity value of the fluorine? Just you remember the electronegativity value of the fluorine. From there, what you do, here you can see fluorine is having the electronegativity value of 4. Electronegativity value of 4. Now come to the which period element? This is a second period element. Now in the second period elements, what we are having? Lithium, beryllium, boron, carbon, nitrogen, oxygen and the fluorine. Fluorine electronegativity value is 4. Then from this 4, just fluor left, from the right to left, you come to the right to left. Right to left means fluorine to lithium you come. When you are coming from the fluorine to lithium, what you do? Decrease the 0.5. Decrease the 0.5 value of its electronegativity. You see, fluorine it is having the 4. Just you decrease the 0.5, you are getting the oxygen electronegativity value. Then decrease the 0.5, you are getting the nitrogen electronegativity value. Decrease the 0.5, you are getting the carbon electronegativity value. Decrease the 0.5, you are getting the boron electronegativity value. Next to beryllium and the lithium. Beryllium and the lithium. Done. Now next, sodium it is having the 0.9. From here you increase the 0.3. Again 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 here you increase the 0.4. You increase the 0.5. Now you see, chlorine it is having the electronegativity value 3 and nitrogen it is having the electronegativity value 3. It is having the same electronegativity values. Next, here Al it is having the electronegativity value 1.5. Beryllium also it is having the electronegativity value 1.5. But here the hydrogen electronegativity value is 2.1. This is very, very important, you have to remember. Hydrogen electronegativity value is 2.1. Clear? If you remember these electronegativity values, it will be helpful for you to identify the which is a ionic bond and which is a covalent bond and which is a polar and which is a non-polar. See, what is the meaning definition of the electronegativity? Tendency to pull the bond pair of electron towards itself. Clear? Now, best example I was taking H and Cl. H and Cl. In H and Cl, here which is a more electronegativity? Chlorine is a more electronegativity, right? This is value is 3. Hydrogen electronegativity value is 2.1. So the chlorine is more electronegativity means what I said, tendency to pull the bond pair of electrons, it is known as a electronegativity. One bond contain how many electron? 2 electron. One bond contain 2 electron. When it is pulling this bond pair of electron towards itself, when the Cl is pulling the bond pair of electron towards itself, what is the charge on the chlorine will get? It will get the partial negative charge. Partial negative charge. Now, what is the charge on the hydrogen it will get? It will get the partial positive charge. Partial positive charge. Due to that, we can say whether this compound is a dipole or non-dipole. Clear? Now, it can take the completely bond pair of electrons towards itself. It will helpful for you in our reagents also to dissociate as a H plus and the Cl minus. Clear? Now, not only identifying the polar and non-polar, it is able to identify the ionic bond and the covalent bond. How? Now we'll see. Here, before going to start the ionic and the non-ionic, ionic and the covalent bonds, I just want to give you some brief idea that in our entire periodic table, which are the metals and which are the non-metals. One thing I will say you one shortcut to remember which are the metals and which are the non-metals. Metal will readily lose the electron. Metal is having the tendency to be readily lose the electron. Non-metals is having the tendency to gain the electron. Tendency to gain the electrons are the non-metals. Tendency to give the electrons are known as the metals. Now you see this one, most of the S block elements having tendency to give the electrons. That's the reason we used to say this as a metals. Now comes here, this blue one are having the tendency to gain the electron. These are having the tendency to gain the electron. These are having the tendency to gain the electron. That's the reason these are behaving as a non-metals. These are behaving as a non-metals, and the middle one are the metalloids. Middle one are the metalloids. Okay. Now comes to the covalent and the ionic bond. How the covalent bonds are forming, how the ionic bonds are forming. First I want to explain how the ionic bonds are forming. First, in the lower classes or in the general, we have studied how the ionic bonds will form. Ionic bonds will be formed by the mutually sharing, by the completely transferring of the electrons from the one atom to the another atom leads to give the ionic bond, we used to say. But here in the ionic bond, Na and Cl, we used to say the bond between them, it is a ionic bond. Na and the Cl, the bond between them, it is a ionic bond. How this ionic bond is forming, whether this bond between them it is ionic or not, now we have to calculate whether the bond between them it is ionic or not. Now one experimentally one trick they have given, but it is experimentally they have given, it may not applicable for the all the molecules, but majority of the molecules it is applicable, but all the molecules it may or it may not applicable. See now NaCl, this NaCl, the bond between them it is ionic or not, now we have to identify. Now you see this is electronegativity difference. If the electronegativity difference, if it is greater than 1.7, if it is greater than 1.7, then we can say the bond between them it is ionic. Bond between them it is ionic. If the electronegativity difference, if it is less than 1.7, the bond between them it is covalent. Clear? If the electronegativity difference, if it is greater than 1.7, ionic. If the electronegativity difference, if it is less than 1.7, that is covalent. Now you see, here NaCl, Na electronegativity value is 0.9, chlorine electronegativity value is 3. The difference in electronegativity 3 minus 0.9, that it will give you the 2.1. So 2.1 electronegativity is greater than 1.7 means the bond between them NaCl is ionic. Now comes to the HCl. HCl electronegativity difference will be, hydrogen electronegativity is 2.1, chlorine electronegativity is 3. Difference between them it will give you 0.9. So the bond between the HCl will be the 0.1. The bond between the electronegativity difference is 0.9 and the bond between the HCl is covalent. Bond between the HCl is a covalent, right? Clear? Now here this whatever the logic we have given, it is experimentally given. It may applicable or it may not applicable for all the compounds. Which compounds it is not applicable? Now you see. Here if I take the HF, now HF, what is the electronegativity? This is 2.1. What is the electronegativity value of fluorine? That is 4. Clear? Now what is the difference between these two? Difference between these two is a 1.9. What I said? Electronegativity difference, if it is greater than 1.7, that the bonds, whatever the bonds that is formed, those are ionic. But here the HF, experimentally we have seen that HF is forming the covalent bond. Not the ionic bond. Clear? That's the reason it is not applicable for the all. Just to identify majority of the compounds, to identify we have using the trick. Clear? Now here those are having the some ionic bonds, some ionic compounds. We are having the some examples of the ionic compound. This is calcium chloride, CaCl2. Sir, how this CaCl2 we can write and how it will be dissociated? For that one we are having a one basic formula and we have to use the one crisscross method. What is the crisscross method? See, whenever the formula it is in this manner, AX and BY type, AX and the BY type. Now the formula by using the crisscross we can write it as a X A power Y plus Y into B power X minus. Now you see, comes to the calcium chloride case, CaCl2. If you want to write this is ionic compound. If you want to write it in the which one, or in the dissociated form, how to write? Here X is 1, so 1 Ca. Now plus Y, right? Y we are having 2, right? We have to write the plus 2. Plus, and how many Cl's we are having? 2, right? Y, and the B is Cl here, and X is 1, so minus 1. In the CaCl2 will be dissociate as the Ca plus 2 and the Cl minus. Ca plus 2 and the Cl minus. Clear? Next, aluminum oxide. Al2O3. Al2O3. How this Al2O3 will be dissociate? How the Al2 Al plus 3 plus 3O minus 2 plus 3O minus 2. In this manner it will be dissociate. These are having the some examples for the ionic compounds, how they will dissociate. How they will dissociate. Clear? Done? Next we'll see the Lewis structures. Majority of the Lewis structures will be explained for the covalent bonds. Lewis structures are explained for the which one? Covalent bonds. Here you see how the covalent bonds. First one I was explaining for the H2SO4. How these H2SO4 are forming the covalent bonds. Best example I will explain for you the HCl1. H and Cl1. How this HCl is forming the which one? Covalent bond. Now you see this chlorine, it contain 7 valency electrons. Done? Now hydrogen contain 1 valency electron. If the hydrogen got 1 electron, it will reach to the duplet electronic configuration. If the chlorine has got the 1 electron, that chlorine will reach to the octet electronic configuration. Now you see, by mutually sharing the electrons, they will leads to give the HCl. Clear? They will leads to give the HCl in this manner, and their octet has been completed. Now here the bond formed, the one bond contain 2 electrons, right? One bond contain 2 electrons. Clear? These 2 electrons are in between the hydrogen and the chlorine. Clear? If I want to draw the Lewis dot structure for this H2SO4. Now you see how to draw the Lewis dot structure for the H2SO4. For the simple compounds we will take one simple compound I will take, that is CCl4 I will take. Then after that I will go to the H2SO4 and all. If I take the CCl4, normally the carbon valency is how much? Carbon valency is 4. Then chlorine valency is how much? Chlorine valency is 7. Done? The chlorine valency is 7. And now the chlorine here, the valency is 7. Now you see, this carbon to complete its octet, it requires 4 electrons. So 1 electron it will be taken by the 1 chlorine, 1 electron it will be taken by the 1 chlorine, 1 electron it will be taken by the 1 chlorine, and 1 electron it will be taken by the 1 chlorine. So this central carbon octet has been completed. The central carbon octet has been completed. Now you see for the chlorine case. Now in the chlorine case, this chlorine also required 1 electron to complete its octet. Now you see this chlorine will take the 1 electron from this carbon and it will complete its octet, and this chlorine it will take the 1 electron from this carbon and it will complete its octet, and this chlorine it will take the 1 electron from this carbon, and it will complete its octet, and this chlorine it will take the 1 electron from this carbon and it will complete its octet. Clear? Now this is the Lewis dot structure of the CCl4. This is the Lewis dot structure for the CCl4. Now comes to the H2SO4. Now you see, normally the sulfur contain how many valency electron? Normally the sulfur contain the 6 valency electrons, right? Okay. Now normally the valency of the sulfur is 6. Now you see here 1, 2, 3, 4, 5, 6. These are the 6 valency electrons for the sulfur. Then sulfur, if it is want to form the bond to reach the octet, how many electrons it should need? It should require only 2 electrons. Now you see here this carbon octet has been completed. Then for the sulfur also, to complete its octet, already 6 electrons are there. If it has taken the 2 electrons, it will reach to the octet. But sulfur, it has extending its octet. Even though it is not satisfying its octet, it is extending its octet. Why it is extending its octet? Due to the presence of vacant d orbital. Now you see, sulfur, if I write the orbital electron configuration, this is 1s, 2s and the 2p, 3s, 3p and the 3d, 3s2, 3p4 and vacant D. Clear? Now the sulfur, what it will do? It will give these electrons to the d orbital, vacant d orbital. Due to the presence of this vacant d orbital, all are having the same energy. N is equal to 3, right? N is equal to 3. If the N is equal to 3 orbit, now if you want to find the energy, of that orbit, how to find the energy of the orbit? We are having the formula E is equal to minus 13.6 Z square by N square electron volt. This is the formula we are having. If you calculate, if you put the 3 square here, you will get the energy of this orbit. So energy of the orbit is same, right? So these electrons will be excited to the empty d orbital, so that when it has extended to the empty d orbital, now S we are having 1 electron, P we are having the 3 electrons and D we are having the 2 electrons. Now you see how many half filled orbitals we are having? Total 6 half filled orbitals we are having. So that sulfur will form the 6 bonds. It can extend its octet. Clear? Now you see, oxygen to complete its octet, it requires how many electrons? 2 electrons. 1 electron it has taken from the hydrogen, 1 electron it has taken from the sulfur. Now you see, here this oxygen to complete its octet, 1 electron it has taken from the sulfur, 1 electron it has taken from the hydrogen. Then 1 electron it has taken from the sulfur, 1 electron it has taken from the sulfur. Clear? Now here, sir, here why only sulfur is giving 1 bond? Why only the sulfur is giving the 1 bond? Here the octet of the sulfur has been, or octet of the oxygen has been not completed. Then how to justify this one? Now you see, normally oxygen valency electrons contain 6 valency electrons. Done? 6 valency electrons. Done? To complete this oxygen octet, it requires the 2 electrons. So normally the H2SO4, how to draw the normally H2SO4? See, this is H2SO4. Sulfur, normally how many valence electrons are there for the sulfur? The normally valence electrons are 6. Then here we are having the, which one? Oxygen. Normally the valency electrons are how many? Oxygen also 6. But to complete its octet, it requires the only 2 electrons, right? So 1 electron it has taken from the hydrogen. So this oxygen octet has been completed. Now you see 1, 2, 3, 4, 5, 6, 7, 8. Done. Next comes here. This oxygen. Now it will take the 1 electron from this oxygen. Clear? Now you see another oxygen it is there. This oxygen to complete its octet, how many electrons it require? 2 electrons it require. Next, another oxygen to complete its octet, how many electrons it require? 2 electrons it require. So it will form the double bond in this manner. This is the H2SO4 structure. So here, instead of drawing this double bond, this oxygen to complete its octet require how many electrons? 2 electrons, right? So instead of drawing the double bond, that to represent that bond, we have to representing in the coordinate covalent bond. Instead of representing the double bond, how many coordinate covalent bonds we are having in the H2SO4, they will ask you. In the entrance exam point of view, they are asking how many coordinate covalent bonds will be present in the H2SO4. When it comes to the oxyacid structures, the double bond, the atom and the double bond O is known as a coordinate covalent bond. See, this oxygen to complete its octet, it requires 2 electrons. Sulfur is giving these 2 electrons in the form of coordinate covalent bond. It is giving these 2 electrons in the form of coordinate covalent bond. That's the reason this oxygen octet has been completed. Now you see, this oxygen to complete its octet, it required 2 electrons. This sulfur is giving 2 electrons in the form of coordinate covalent bond. What is the meaning of the coordinate covalent bond? Means only one thing you remember. These 2 electrons are present in between this sulfur and oxygen is known as the coordinate covalent bond. So instead of making charged species, to make it the neutral species, we have introduced the coordinate covalent bond. Clear? Now we see next. Lewis acids and the Lewis bases. What is the Lewis acids and what is the meaning of the Lewis bases? This Lewis acids and the Lewis bases will play very crucial role in the reagents. What is a Lewis acid? Electron pair acceptor are Lewis acids. If the electrons are accepted, those are Lewis acid. Clear? Now, electron pair donor are the Lewis bases. Electron pair donor are Lewis bases. Electron pair acceptors are Lewis acid, electron pair donors are the Lewis bases. Example, if I take the AlCl3, why this AlCl3 has become the Lewis acid? Why this AlCl3 has become the Lewis acid? Now you see, 1s2, 2s2, 2p6, 3s2, 3p1, 3p1. Clear? Because Al atomic number is 13. Now 13 electrons has been filled. See how many orbitals are vacant here? How many orbitals are vacant here? For the Al, 2 orbitals are vacant. As the same way, 3d also vacant. 3d also vacant. Clear? So this Al can accommodate the electrons in these empty orbitals. It can accommodate the electrons in these empty orbitals. So this Al is accepting the electrons from the any donor species, right? Those Al, these are neutral electrophiles. We used to call this as a neutral electrophiles. Even though those are not having any charge, we are calling it as a Lewis acid. Why? Because Lewis acid can accept the electron. But where it can accept the electron? They can accept their electrons to these empty orbitals. Due to the accepting of the electrons in those empty orbitals, that's the reason these are behaving as a Lewis acid. What is the meaning of the Lewis acid? It can accept the electron. Clear? Now neutral electrophiles are called as a Lewis acids. Clear? AlCl3, AlBr3. Clear? Now CO2 is also a one acid. How the CO2 will accept the electron? Now you see, this carbon and the oxygen. Now this carbon and the oxygen, which is more electronegative? Oxygen is a more electronegative. This oxygen, what it will do? It will take the bond pair of electron. This bond pair of electron has been taken by this oxygen. When this bond pair of electron has been taken by this oxygen, now oxygen will get the negative charge. Clear? Now this carbon will get the positive charge. If this carbon has got the positive charge, for which orbital it will be accept? Now you see, this normally carbon can form the 4 bonds, right? Ground state electronic configuration of the carbon is 2s2, 2p2. 2s2, 2p2. This is the ground state electronic configuration of the carbon. When it has formed the 4 bonds, means one electron has been excited. This excited state electronic configuration, that excited electron will move to this empty 2p orbital. This is 2px, 2py, 2pz. Clear? When it has moved to the one excited state electronic configuration, done. Clear? Now here this oxygens has been formed the bond between this one and bond between this one. Clear? Now here one oxygen electron, here also one oxygen electrons. Done. Now this oxygen, what it has did? It has taken this carbon electron towards itself. This carbon 1 electron has been taken by the oxygen. When this carbon 1 electron has been taken by this oxygen, oxygen will get the negative charge. This orbital is empty, right? This p orbital is empty. For the carbon, now this p orbital is empty. For this p orbital, for this carbon, this p orbital is empty, right? For that one, that electron will be accepted. That carbon, it will accept that electron to the which one? Empty orbital. If the carbon got the positive charge, means you have to be blindly, you have to believe that carbon has lost one electron. Carbon has lost one electron and it is having the one vacant p orbital, and it will accept that electron to that vacant p orbital. Clear? Now this is a application and this is a concept you have to remember. Every time the faculty will get what? It will get stubborn to say every time carbon it is having the vacant p orbital. Clear? And in that it will be accepted because the faculty it will be in this mood that he has already has explained in the in the chemical bonding. So why to recap it again? So not to get any difficulty. I know every student is having ability to forget. That's the reason I was recapping here. Where the carbon will accept that electron. Carbon will accept that electron to this empty orbitals. Clear? Done? Now, next we will move to the formal charges. Why these formal charges has came? Just now in the starting of the lecture, I was discussed about the coordinate covalent bond. I used to say, sir, what is a coordinate covalent bond? You may get a confused. To rectify that confusion, now this concept of formal charges has came. This concept formal charges has came. What is the formal charge? What is the formal charge? First example I will say. First I was taking one well-known example for you, that is ozone. This is a ozone. Clear? Now ozone is neutral in nature. Charged species are unstable. In the chemistry, the first point you have to remember, that is any charged species if they have given, that is unstable. So ozone, this is having the stable in the compound, but due to the presence of these charges, it is becoming unstable. To make it the more stable, so we have to remove the charges on them. How to remove the charges on them? For that one, now you see, oxygen O2, one oxygen contain 6 valency electron, right? Now this two will form the bond. Clear? Now all the two oxygens octet has been completed. Now another oxygen has been came. Now another oxygen has been came to this O2. Now to complete this oxygen's octet also, what this oxygen has given, now it has given these 2 electrons to this oxygen, so that this oxygen octet has been completed, this oxygen octet has been completed. Not to represent the charges on the atom, we have introduced the one special type of the bond. That type of the bond we call it as a coordinate covalent bond. Why we have introduced the coordinate covalent bond? To not to represent the charges on the atoms, we have represented the coordinate covalent bond. What is the coordinate covalent bond? Mutually sharing. These 2 electrons are between this oxygen and this oxygen. See, if you represent in the form of covalent bond, you have to represent the formal charges. If you don't want to represent the charges on the atoms, then you have to represent in the form of coordinate covalent bond. If you represent in the form of coordinate covalent bond, there is no need to represent the charges. If you have not represented the charges, if you want to represent in the covalent bond, means you have to represent the charges on the central atom. To not to represent the charges on the atom, we have introduced the one special type of the bond called as a which one? Coordinate covalent bond. So how to calculate this coordinate covalent bond? There we are having a one formula. Formal charge is equal to number of valency electrons minus number of bond pairs minus 2 into number of lone pairs. Number of lone pairs. This is a formula to calculate the formal charge. So I want to calculate the formal charge of this oxygen. Central oxygen 2 number oxygen. This 2 number oxygen, number of valency electrons are, how many valency electrons for the oxygen will be 6. Then number of bond pairs, how many bond pairs we are having, 1 2 3, right? 3. Clear? Now 2 into number of lone pair, how many lone pair of electrons will be this oxygen will have? Now you see here 1 2 3 4. Here this oxygen is having the 2 lone pair. Now this oxygen is having the how many lone pair? 1 2 3 4 5 6. 5 6. Clear? Now this oxygen is having only the one lone pair of electron, because one lone pair has been given to this oxygen, right? And another lone pair of electron has been participated in the bond formation. So this oxygen contain only one, which one? One lone pair of electron, right? So 2 into 1. Then the formal charge will be 6 minus 1, that will be the plus 1. That's the reason the formal charge on the central axiom is plus 1. Done? Clear? Now next we are going to see about the dipole moment. Now dipole moment. How to calculate the dipole moment? Here this dipole moment, to make you to understand very clearly, first of all I want to explain you the hybridization. So now what I was doing, I will stop the lecture here. Now next lecture, the continuation part of our basic organic chemistry or application part of the organic chemistry, what I will do, I will explain first hybridization in the next lecture. Then after that we will continue our organic chemistry with the followed by the IUPAC, functional group, isomerism, GOC, and the n number of the question. Now we will continue our lecture. Okay, done. Now see you in the next lecture. Bye.